the stars in there actually dissolved as point sources, which is remarkable. And then as we have
Absolutely. So honestly, it took me a while to figure out. We saw it in a different kind of light when Hubble took it.
Hi, this is Adam for Jason Adam TV on YouTube. Tonight, or this morning, depending on which part of Earth you live on, we got the first images from the James Webb Space Telescope. Why is this such a big deal? Well, the James Webb Space Telescope has a much bigger aperture than the Hubble Space Telescope. It has an aperture of about 6.5 meters, while the Hubble had an aperture of about 2.4. What that means is the James Webb Space Telescope can take in much more light and detail than the older Hubble Space Telescope. There are also some other differences. I'm not going to go too much into specifics, but the Hubble was designed to capture visible light, and the James Webb Space Telescope was designed to capture infrared and near infrared. So let's take a look at the first images which NASA just released. The first one is the deep field picture. And this picture is extremely interesting because it shows the effect of gravitational lensing. Gravitational lensing is the bending of light and magnification of light from very, very far away. In this case, as far as 13 billion light years away. So it's acting like there are some dense objects in the center that are acting like magnifying glasses. And they are magnifying these very, very distant galaxies, ones that are up to 13 billion light years away, at the very infancy or very beginning of our universe. So you can see a lot of these galaxies are bent. They look crooked. If you zoom in a little bit, you can see one that looks kind of like a pancake or an omelet. So this is due to the gravitational lensing effect. Also, the reddest galaxies are the ones that are furthest away. So you can see some galaxies are redder than others. Those are further away than the ones that are bluer or yellowish colored. Another interesting thing is the number of galaxies in this picture. This is just a tiny sliver, a tiny fraction of the night sky. And you can see thousands of galaxies in this picture. And each galaxy on its own contains billions of stars. And these stars most likely have planets around them. So there are trillions of planets in this picture. We just can't see them. If this doesn't give you an idea of how insignificant and how small the Earth and our solar system are, then I don't know what will. This is just a breathtaking image. It's hard to fathom how great, how large the universe is. But you get some idea by looking at this deep field picture. Okay, the next picture I'm going to talk about is the planetary nebula. So a planetary nebula doesn't involve planets. It is actually a star that is dying, a star like the sun. So when the sun dies, our sun dies, it will first expand into a red dwarf as it burns through helium and then some higher elements. When our sun gets to the higher elements, the heavier elements, the pressure of gravity will be greater than the pressure created by the fusion reaction in our sun's core. And what will happen is the sun will collapse and it will create a white dwarf, and around the sun will be the expelled gas, and that's what creates a planetary nebula. So looking at this picture, again, if you zoom in, you can see the details of the gas that has been, the clouds of gas that has been expelled from the stellar core. Again, a very amazing picture. And one of the scientists pointed out at NASA, there is actually an edge-on galaxy in the outer fringes of this planetary nebula, right here in the picture. So again, another very interesting detail, and you can also see other galaxies behind the nebula if you look closer. So again, an astounding picture. I mean, even though the planetary nebula is the brightest thing in the picture, you can still pick up faraway galaxies in the background if you zoom in. Okay, the next picture that I'm going to, that one hasn't loaded yet. Okay, let's go to this one. This is the Carina Nebula. So this is a stellar nursery. There are tons of stars being born in this nebula. And it looks beautiful. You can see the gas in the nebula, and you can see all of these stars speckled across the gas of the nebula. So another amazing picture from the James Webb Space Telescope. The detail is, again, amazing. If you zoom in, you'll notice there's an hexagonal artifact around the brightest stars. That's due to the shape of the mirrors on the James Webb Space Telescope, but it doesn't affect the resolution of the telescope itself. Okay, let me reload this picture. There should be a picture of Stephen's quintet in here. And this is a group of 5 galaxies that are locked in a gravitational dance around each other. And is also a very, very interesting picture. Let me go back and click on it again and see if I can get this picture to load. Okay, there we go. It is loading now. So again, the amount of detail that is captured in this image is just amazing. If you compare it to the Hubble Space Telescope image of the same 5 galaxies. So if I remember correctly, these galaxies are about 300 million light years away.